Alright, section 1.3 has to do with the distance and the midpoint formula. This is all review from what you've had from Algebra 2. So I'm in Algebra 1. So the distance on a number line versus the distance on a coordinate plane. If you have 2 points on a number line, to find the distance between those 2 points, you just subtract one from the other. So you can either say the absolute value of A minus B or the absolute value of B minus A. For instance, let's say you have a -4 over here and you have a +6 over here. To find the distance between -4 and +6, you're just going to go the absolute value of -4 minus 6, that's going to give you the absolute value of -10. So the distance between -4 and +6 is going to be 10 units. Now, obviously, when you are on a coordinate plane, you can't do that. So the distance formula on a coordinate plane is actually derived from the Pythagorean theorem. So if you actually made a triangle out of this and you said this squared plus this squared is going to equal this squared, then you've used the Pythagorean theorem to find the distance from this point to this point. From the Pythagorean theorem, we have derived what's called a distance formula. The distance from here to here is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now it doesn't matter which point you choose to be y sub 1s and x sub 1s, just as long as it's consistent. If this is x sub 1, this has to be y sub 1. If this is x sub 2, this has to be y sub 2. Now, because you have the formula for the distance between 2 points on a coordinate plane, you don't have to put it on a graph. In fact, many times it's way easier. So I'm going to do it both ways, where I put it on the graph and where I just use the formula. So if I graph this, the point -4, +1 is right here. And the point 3, -1 is right here. Now, what I'm trying to find is that distance right there. So what I could do is I could do the Pythagorean theorem here. So I know that the distance between, this is a -1 right here, to a +1 is 2 units. The distance from a -4 to a +3 is 7 units. So I can sit there, I want to find that solid line, so I can go 2 squared plus 7 squared is equal to the c squared. The c is going to be the distance between those two. So I've got 4 plus 49 is equal to c squared, or we can say this is 53 is equal to c squared. So c is going to equal the square root of 53, which is approximately, you can pull your calculator out, 7.28. All right, so this would be using the Pythagorean theorem. But I would not encourage you to do it that way. I would encourage you to use the distance formula. So I have the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So it doesn't matter which one of these you choose as the sub 1s and the sub 2s. Typically, I go from left to right or up and down if they're listed top and bottom. So I'm going to go -4 minus 3, so the x's go together, squared, plus 1 minus a -1 squared. So that's going to give me -7 squared, which is going to be 49. And this is going to give me 2 squared, which is going to give me 4. So I'm right back at the square root of 53, which we discovered is 7.28. So this is using the Pythagorean theorem. This is using the distance formula. Really, the only one you have to remember is this one. The midpoint formula, on a number line, you just take the two values and you add them together and you divide by 2. The midpoint is basically the average. So again, if I have, let's say, a -4 and a +6, I'm going to add -4 plus 6, and I'm going to divide it by 2 because there's 2 points. So that's going to give me a +2 divided by 2, which is 1. So the distance halfway in the middle between these two would be +1. So that's the midpoint. Midpoint means exactly in the middle. Again, when you put it on a coordinate plane, life is a little different. But you are still finding the average of the two x's. So you take x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2, and divide it by 2. Again, you've had all this before, so it should be just review. Let's say I want to find the coordinates of the midpoint for GH. So the midpoint x I'm going to take the x values, so 8 plus -14, so here's the x values, and I'm going to divide it by 2. So that's going to give me a -6 divided by 2, or a -3. So that's my midpoint x. So what's exactly in the middle between these 2 points x-wise is -3. So then I need to find my y, doing it the exact same way, but using my y values. So I have got, here's my y's, -6 plus 12 divided by 2 is going to give me a +6 divided by 2, or a +3. So the point that lies exactly in the middle on a coordinate plane between those 2 points is -3, +6. Sometimes they'll give you one of the endpoints and a midpoint, and you'll have to work backwards to find the other endpoint. So here's an example of that. So it says, find the coordinate D if E, -6, 4, is the midpoint of DF, and F has the coordinate of -5, -3. Now, you really don't need to put this on the coordinate plane, but I want to show it to you on the coordinate plane so you can get an idea of what we're doing. Okay, so I have the point -6, +4. Okay, that's my midpoint. Okay, so I'm going to put an X as the midpoint. That's -6, 4. See how it says E is the midpoint? Okay, F is -5, 1, 2, 3, 4, 5, -3. So that's this point right here, -5, -3. So what we're looking for, so here's my line, I am looking for what this point is up here that the X, or the midpoint, is exactly in the middle of. So I know the answer to my midpoint formula, and I know one of my numbers. So midpoint X, remember the formula, is equal to x sub 1 plus x sub 2 divided by 2. So I know this and I know this, so I just have to plug it in. So the midpoint x is -6, and one of my x's is -5, but I don't know my other x. So I have to solve for x. I'm going to multiply both sides by 2. So this is going to give me a -12 is equal to -5 plus x. I'm going to add 5 to both sides, and that's going to give me a -7 is equal to x. So I know that the x value of that is -7. Then I'm going to do the same thing for the y. So I have midpoint y is equal to y sub 1 plus y sub 2 divided by 2. Again, I know the midpoint y, and I know one of the y's. So the midpoint y is 4. The other y is negative 3, but I'm missing a y. Okay, I'm missing the y from up here. So I multiply both sides by 2, and I have 8 is equal to negative 3 plus y. I'm going to add 3 to both sides, so that's going to give me a positive 11 equals y. So I know the y value of the other endpoint is 11. Okay. All right, you can also use the definition of midpoint to solve a problem. So let's say I know that B is the midpoint of AC. That means, definition of midpoint says the midpoint is exactly in the middle. So that means that this value is equal to this value. So I'm literally going to make an equation that shows that. And I'm going to then turn around and use algebra to solve for x. So negative 2x, negative 2x. I'm going to put the x's on the left-hand side. So I have a 2x minus 5 is equal to 11. I'm going to add 5 to both sides. So I have a 2x is equal to 16. Divide by 2. X is equal to 8. Okay, so that's solving. So here's another example of a problem where the midpoint is used, the definition is used to solve the problem. If it says Q is the midpoint of PR, that means Q is exactly in the middle of these two. So if QR is 6 minus 3x, then PQ is also 6 minus 3x. So this plus this would have to equal that. So I have 6 minus 3x plus 6 minus 3x is equal to 14x plus 2. So I have 12 minus 6x is equal to 14x plus 2. I'm going to subtract the 14x from both sides. So I have 12 minus 20x is equal to 2. I'm going to subtract the 12. So now I have negative 20x is equal to negative 10. When I divide by the 20, I'm going to get negative 10 over negative 20, which is the same thing as 1/2. So the x value up here is going to be 1/2. All right, homework on this is page 25 through 26. 14 through 44 even. Now if it says to solve by the distance between the 2 points using the Pythagorean theorem, you don't have to do that. You can use the distance formula instead, so you don't have to put it on a coordinate plane.